Next thing is law of cosines, and this is also used to find your angles and side measures when you don't have right triangles. And this is kind of the more involving formula, but it works in more places than law of sines. So you'll quickly see this is a little more complicated. And law of sines is really easier to use, but you'll see that this works in a lot more situations. So use law of sines when you can. When you can't, this is kind of your fallback. So it's really kind of a specialized version of Pythagorean theorem, and you kind of see Pythagorean theorem happening in the beginning part. So as far as remembering how to use it, it definitely starts off as Pythagorean theorem with a little bit of an adjustment because it's not a right triangle. So before we get into all the pieces here, remember that usually your angles are going to be a capital letter. And usually side measures are lowercase letters. That's just kind of the convention you're going to see everywhere. So I'm starting with all these lowercase letters because these are side measures. So again, it starts with Pythagorean theorem. Now pay attention to the side that's by itself. This is pretty important. So I'm using this side right here by itself. The rest of the formula is going to be minus 2 times these other two sides, B and C, times the cosine of the angle across from the side I'm looking for. So a couple of little points down there. I mean, really, if you can just remember this stuff, whatever side you're using, that's the one by itself. The angle across from it is the angle you're going to take the cosine of. And then all the other stuff in here is just the other two sides you haven't used, the other two sides that aren't this one. So that's really the key, and I'm going to show you a couple of examples here in a second. So here's kind of the classic place to use this when you've got two sides, you've got the angle between them, and in a real life situation, if we had two measurements and we were standing at a point where they come together and we can measure this angle between the two points, then we can use that to figure out the distance between two things off in the distance. That's kind of the classic use of this. It's also pretty much the easiest. So we're trying to find x, and it's across from this 34-degree angle. So that's going to be what we need to set up. We want to put x by itself and square it. We're going to take these other two sides and square them and add them together. So it starts out Pythagorean theorem. Except you don't have to use the hypotenuse all the time here. You just have to use whatever side you want. With the catch that you're going to be locked into using the angle across from it later on. That's the only catch. So one side goes here, the other sides are squared here. Now, once you pick those two, it's minus 2 times both of those, 105 and 176. And then also cosine of that angle, 34 degrees. If you take cosine of an angle, so I plug it in the parentheses there. Just be careful with parentheses. It doesn't hurt to go ahead and put all this stuff in brackets or extra parentheses just to keep it all straight. That's really the biggest error I see, is just some kind of parenthesis issue going on. Be careful. If you're prone to make mistakes with parentheses, then just break this apart. Take it a piece at a time and you'll be okay. Now I've already got this stuff loaded in the calculator. It's ready to go. I just put everything in one set of parentheses there, and that should be okay. And when I do that, when I hit enter, I get 11,359. I'm just going to round up to the nearest whole number here in a second because I'm getting ready to take a square root, and that decimal is really not going to change things much. So 11,360. So x squared, that's important, is 11,360. Just be careful bringing things down. And really, I'm going to use the whole decimal number when I take this square root anyway, but that's how I need to solve for x. I need to take the square root of both sides. So square root of that number, so second and x squared. And I'm going to go up and highlight that number right there, hit enter so it puts it underneath the bracket. And now I'm taking square root of everything with the decimal, so it really didn't matter how I rounded it on the other page. So I'm getting 106.6. We'll round to one decimal place. And there weren't any units to attach. If it was in feet or meters, you definitely would put that on there. But that's going to do it. That's going to be 106.6 for that side measurement. And make sure it seems to make sense. Looks like it's pretty close to the same length as that one, so should be good. Of course, this isn't really drawn to scale either, so that should be good to go. Another really common use of this is going to be when you have all the sides, but you don't know any of the angles yet. So we got to start somewhere. Might as well start with A. Now I'm going to look for angle A, and the side across from it is 39. So that's the one that's going to be by itself, 39 squared. And that's going to equal the other two things squared and added together, minus 2 times those two things. And I'm going to scoot this whole thing down just a little bit, give myself a little more room, times the cosine of A, which I don't know yet. Be really careful, take this kind of slow. I would break it up in parts. You really can't do all this at one time in the calculators. If you try, you're going to really mess it up. So do what I'm getting ready to show you here, and you'll be better off. So take it slow, 39 squared. 39 squared is 1521. Let's go ahead and put that in. All right, these two I'll go ahead and do together. 57 squared plus 63 squared. That's 7218. Now, there's a minus right there. All of these are multiplied together. There's 1, 2, 3, 4 things multiplied together. 3 of those contain numbers, 1 is a variable. So, multiply your numbers together, but keep it attached to that variable right there. So 2 times 57 times 63, that's going to give us 7182. That's interesting how that's just those numbers moved around. But again, keep that cosine of A attached to it because they were all multiplied together. Number one mistake I see is just botching this part. Just keep your algebra straight, you'll be all right. All right, now, again, keeping your algebra straight. Number with a variable attached to it. Get your pure numbers together first. So, let's subtract 7218 from both sides. And let's see what that gives us. 1521 minus 7218. That's going to give us negative 5697. And I'm going to keep this part the same. Not doing anything at all right now. So I just brought that down. Keep that negative in there. Another really common mistake. It was there in the beginning. It's got to continue to be there. You didn't get rid of it, so keep it there. All right, now you're trying to get a variable by itself. You got something multiplied by it. So divide that out. So divide by the 7182. And it does need to be negative. All right, we get that decimal. I'm going to round it off over here to 0.8, which really doesn't matter because I'm getting ready to do a lot more stuff in the calculator. So 0.8. If you think about an angle, that's really not going to make a lot of sense in degrees here. So it can't be 0.8. You got to have 180 degrees inside that triangle. It's just way too small. So we got to figure out what A is, and it's not 0.8. The cosine of A is 0.8. So we need to do the arc cosine or inverse cosine. We need to do that on both sides. And that's also a function, so it's going to open up parentheses. So what I'm going to do is second cosine to bring that up. And the reason I didn't worry about all these decimal places, I'm going to go up here and highlight it, hit enter. It's going to put it in parentheses right there for me. And then we'll get an answer. I'm just going to round to the nearest tenth, so 37.5 degrees should be good enough. So A is 37.5 degrees. Now, at the beginning I said if you can use law of sines, use it, it's easier. And now we're in a position where we can. We need to find these other two angles, but we certainly have enough information now to use law of sines. So I'm going to start with the angle I just found. I'm going to do it a different color so it stands out a little bit. Sine 37.5. Now, it kind of locks me in because I've got to use 39 underneath it. And B kind of makes sense to be the next thing to find, so sine of B, and 63 is across from it. And we have a proportion. So best move now is to cross multiply, which is really just multiplying by the denominators on each side. So I'm going to start off with 63 times sine 37.5. That gives me 38.35. All right, so I've got my decimal number, 39 times sine of b. Really, there's nothing to do except just show that those did get multiplied together. But now that means we can divide both sides by 39 to get it by itself. So let's see what that comes out to be. Now I'm just keeping all these decimal places in here. There's really no need to type all that stuff back out again. And I get another decimal answer. Now, again, that can't be my angle measure. It's too small. That's an obtuse angle. I already know it's more than 90 just looking at it. It can't be 0.9. So that decimal I got, that 0.98, that is the sine of b, because that's all that's left over there. This is another situation where you've got to take that arc sine to get the angle by itself. So you're going to do second sine in the calculator. And we're going to take that of this decimal that we got. And again, I'm going to go up and highlight it, hit enter. There's no need to type all that stuff back in. So I get about 79.5 degrees. And I'm going to have to go back on something I said a second ago. And that's just because my triangle isn't to scale. It looks obtuse. And if all these numbers were to scale, then it would be obtuse. But anyway, it's pretty close to 90. Without the numbers, that's what it is coming out to be, so I wouldn't worry about that. All right, last thing is C. C is the easiest thing to find. You can go back and use law of sines, law of cosines if you really want to get the practice in. But at this point, you have two angles, and you should remember from geometry that your three angles add up to 180. So take 180 and subtract off the 79.5 you just found, and subtract off the other one that was 37.5. And the last angle is going to be 63 degrees. So there you have it. There's A, B, and C, and you've got them all.